Welcome. We have a new problem. In fact, second in series of switching the key from one position to another. And you can see a problem at your screen that simply asks what charges will flow through points 1 and 2 after closing key K in the circuit shown in the figure. Consider the case E1 equals E2 equals E. That's all right. Fine. So let's solve this problem. You can see before the switch is closed, that means this switch is open, the capacitors are connected in series and the charges on each of them is equal, of course. And if I call the charge on capacitor C1 as Q1 and charge on capacitor Q2 C2 as Q2, they are both going to be the same, and their values will be simply E2, that is E, multiplied by equivalent of those capacitors, since they are connected in series. So we can write something like this, and this is our equation 1. And now if we close the key, so the new charges on the capacitors will come, and suppose in this case it has got a charge Q1 dash, the capacitor C1, and capacitor C2 as Q2 dash. Then I think we can write some circuit equations, and that is I guess for this circuit you can simply write here E1 equals Q2 dash by C2, and for this circuit again you can write E2 equals Q1 by C1, Q1 dash by C1 plus Q2 dash by C2. This is the set of equation 2, and I can guess now that we can find the charges on the capacitors Q1 dash and Q2 dash, and for this we have got simply as Q2 dash equals E1 C2 and Q1 dash equal to E2 minus E1 C1. That is going to be 0. But for now we will keep writing in terms of E2 and E1. So, and now I can see one thing, I can watch one thing important, that is I can say here that if we focus on point 2, this point, we notice one thing, the charge of capacitor C1 can only be changed along the path through point 2, because path 1, the point 1 doesn't come into its path. So point 2 is responsible for the changes in the charges on capacitor C1, and we can see that change in charges through point 2 is the change in charges of capacitor C1, and if I write the change in charges through point 2 by delta Q2, it will be the change in charge on capacitor C1, and that is nothing but Q1 dash minus Q1, and you can calculate both of them because we already have the values of Q1 and Q1 dash, and you are going to get it something like E2 minus E1 C1 minus E1 C1 C2 by C1 plus C2, like this, not E1 but E2 in fact. Here it is E2, and this is, let's write it E, that is I have previously written, and it looks good in this manner. Now you will have to notice another thing, that is about point 1, and I'm not talking alone about point 1, but if we see, if we try to analyze the change in charges of capacitor C2, then it has come through both the points, point 1 and point 2. Point 1 later after the switch is closed, and before the switch was closed it has came through point 2. So I can write that the sum of charges passing through point 1 and 2 both, point 1 and 2 both, that is delta Q1 plus delta Q2 is equal to the change in charge of capacitor C2, and the change in charge of capacitor C2 is simply Q2 dash minus Q2. And considering this equation, we can write change in charge through point 1 is equal to Q2 dash minus Q2 minus delta Q2, change in charge through point 2, and you can calculate this and you will get this is simply E1 C2 plus E1 minus E2 C1. And we know now that since E1 equals E2 is equal to E itself, so we can write here delta Q2 equals this term becomes 0, so answer is simply minus E C1 C2 by C1 plus C2, and the change in charge through point 1 will be simply here, and this term becomes 0, so its answer is E1 C2, and that is not E1, basically it is simply E, because E1 equal to E2. And that's all. Thank you for watching.